All right, so this is session 1B. This now is the calculator active. Let's take a look. Their directions, begin test. Calculator active 1B. All right, 1B. Sorry, I get to go a little slower than my other video. 1B will have 1B is the first calculator. 1B has 1, 2, 3, 4, 5, 6 questions in 1B. But the good news about it is that it has a calculator. Okay, so we are able to roll and go. All right, so here we have graph this absolute value. Then it wants us to graph it here. So I go into Desmos, and I enter in the absolute value. Absolute value is this symbol right here, the absolute value of A. All right, so I need to put a negative in front of that. Absolute value of 2x minus 6. Close the absolute value, right? And then plus 1. So there it gives me points, right? But those points I'm not really able to use those because those are 3.5s and we can't do those. So what you have to do is click the edit list and you have to click the convert to table. And so that way it's going to give you some points, okay? You see how it kind of created a table for you and it gave you points for you to use. And so now I'll just extend this. Well, what's 3, enter, 4, right? Enter 5, enter. So there it gives us points or whatever for us, our points to use. Okay, so now we have a table. We have points to use. I'm going to move this over out of the way so that way I can still see it and use it. All right, so I'm going to do points. This is a closed point. My vertex is at 3, 1. So I'm going to go to 3, 1. Okay, I select my next point that I'm going to have here. Next point is at 2, negative 1. So 2, negative 1, that's right there. This point here is at 4, negative 1, which is right here. I choose my line, click that point, make it go through that point there. All right. Click that point, click it again, make it go through that point. All right, there's my next point according to my graph. So I'll just have my on there, make sure it's close, and there you go. All right, and that is how you graph that, especially with the calculator. Leah would like to earn at least $120 per month. She babysits $5 an hour and works at an ice cream shop for $8 per hour. Leah cannot work more than 20 hours per month. X represents the number of hours that Leah babysits, and Y represents the number of hours at the ice cream shop that she represents. Okay, so this is going to be if she works 5X, that's babysitting, plus 8Y, which is the ice cream shop. She wants to earn at least, which would be greater than or equal to $120. Now her hours at X plus her hours at Y have to be greater than or equal to 20. So those are my two equations. So I can click. All right. At this point, I can come up here and click Desmos. I enter in these equations that I got. So that's 5x plus 8y is greater than or equal to 120. All right. And then x plus y is less than or equal to 20. So here, zoom this out a little bit. Here is what it looks like. All right, so here is what my graph looks like. Is there any, based on what this graph looks like, I can get rid of, let me get rid of my markings here because I don't need them. All right, anything that I can get rid of, again, the double shaded area is here. The double shaded area is here. So it's not this one. It's not this one. The only one that's possible is B and C. But take a look here, okay? If I look, this has a point at 0.20 and then another point at 0.15. This has a point at 0.20 and then 0. If I had to guess, that was like 0, maybe in 15, 20, half is 17.5. So maybe 24 roughly. That's not what this shows. So it's not that one. So B has to be my answer. Okay. So B has to be my answer. I move on. Same question. It wants to know, hey, are these answers? Go back into Desmos. Make sure you write stuff down on your scratch paper. Write it down on your scratch paper so that way you can very easily punch this right back in. Write down your equations on your scratch paper so that way you know that you have them. Okay. Right. Or what you also can do is this. Okay. Write these down on your scratch paper. 415. Click the back button. Right. Click the back button. 415 is right there. If it's close, it's in there. Okay. So 4 is there. 15 is there. So yep, that's an answer choice. All right. B is 512. So I click back. 512 is about right there. Yep, that's close. So yep, that's in there. So I click that. 10.9. Click back. 10.9 is about right there. 10.9 is about right there. So, yep, that's an answer choice. 15.5. Here's what I'm saying about if it's close, it's there. 15.5. 15.5 is here. It is not in the double shaded area, right? 15.5 is here, not in the double shaded area. So, it is not an answer choice. 19.1. 19.1 is going to be 19.1 is going to be here and here, not in the double shaded area. So again, that's not an answer choice. Leah wants to babysit 7 hours this month. What is the maximum number of hours that she would have to work at the ice cream shop to earn at least $120? Okay, so again, I have my equation, right? My equations that I had, and again, you wrote these down on a scratch piece of paper, right? Your equations are 5x plus 8y is greater than or equal to 120. X plus y is less than or equal to 20. Okay, so we have our two equations here. And so it says that if she babysits for 7 hours, remember it says that babysits, right? Babysits was X. So if she babysits for 7 hours, what is the minimum number of hours that she has to work in order to receive that? So I go right back into Desmos, This is 5 x plus 8y is greater than or equal to 120. This is x plus y is less than or equal to 20. And this is saying, well, what about if x is 7? Okay. If x is 7. Well, if x is 7, right, that's here. If x is 7, what is the minimum number of hours that she can work? That's minimum. Up here at the top, that would be maximum, right? So there's the minimum. The minimum is 10.625. Okay? And it says here, all right, so 10.625, give your answer to the nearest whole hour. So if I had 10.625, that's 6, rounds that up plus 1, giving me 11. So this is 11. She prefers babysitting over the ice cream shop. So out of 20 hours, what is the maximum number that she can babysit and still be able to work, make $120? Okay. Well, that is asking a vertex question. Okay. That is asking the vertex question. All right. It's asking you this. What is the maximum number of hours of X? Okay. Maximum number of hours of X. What is the maximum value of X? And what is the minimum value of Y? Well, that is called the vertex. That is where these two come together. So the maximum value is 13.333, 13 and a third hour. Give your answer to the nearest whole hour. All right, 3 goes back, okay? 3 goes back to 0, making this just 13. So the answer here is 13. So this would be 11, and this would be 13, right? Move that forward. So I have a function here of ax plus c equals bx plus d. A cannot equal b, c cannot equal d. What is x expressed in the terms of a, b, c, and d? All right, so this is just manipulating this formula. This is just manipulating it. Ax plus c equals bx plus d. All right. So the first thing that I have to do is get the x's on one side. So I will say subtract the bx from both sides, giving me ax minus bx. Okay. And then this c doesn't need to be over here, so I'm going to subtract the c from both sides. So that just leaves me with a d minus c. Okay, that leaves me with a d minus c. Well, this has an x, greatest common value, common factor of x, so I can take that x out, leaving me with a minus b equals d minus c. Divide both sides by a minus b, and x equals d minus c over a minus b. So that would be, this goes there, this goes there. All right, so the worker earned 2% of her annual salary of 4 years. She plans to continue working in her position for additional N years. If she continues to earn 2% in her annual salary, which statement describes the expression that can be used to calculate the total percent increase in her annual salary from the first year to the last year? All right, so we have, well, naturally this. If you go to work, you're going to work 100%. You're going to get paid 100% of what you're owed. If you get paid anything else, that's dumb. Okay? So she gets paid 100% of her salary plus a 2% increase, which that is 102%, which is 1.02. Okay? Which is 1.02. Okay? Everything has 1.02, 1.02, 1.02. Everything has 1.02. All right. So she's going to get this each of the 4 years, right? Each of 4 years, right? So she's going to get this. She's going to get that 0.02 each of the 4 years. That's going to become an exponent. She plans to continually work an additional adds the root word in years. So that means plus in years. That means that I can go ahead and I can get rid of this one and I can get rid of this one because these are the only ones that have n plus n, right? So now, what makes this a true statement? And the only way that this is a true statement is, again, if you know your law of exponents, right? In order to add like bases, in order to add like bases, add exponents, there's no way for me to delete this without deleting the whole thing. Let's just do it. All right, in order for you to be able to, in order to add the exponents, you have to multiply like bases. All right, multiply like bases. That means that That's the answer there. All right. Determine which ones, determine whether one of each. All right, so there's your first question. The question is rational or irrational. Each number, so there's an A and a B, is the product there. So there's your second question. All right, so number one, I'm going to say A. A is a repeat, so it's rational. So A, all right, so I'm going to say A is rational because the decimal repeats. All right. For part B, I'm going to say B, right? It doesn't repeat and it does not terminate, so that's irrational. Is irrational because the decimal does not repeat or terminate. All right. Number two, is the product of A times B rational or irrational? Well, we've already said in a previous question, whatever it was, number three or whatever it is, the only way to get a rational number out of an irrational number is to square it, okay? So the only way to get a rational number out of an irrational number, all right, is to square it, okay? So the only way to get it is to square it, okay? So if I were to multiply these, right, you have a calculator. You have a calculator. If I have a calculator, right, I have a calculator, I have a calculator, I have a calculator. I'm going to say 0.4444444444 times 0.3355435554, and I'm gonna hit enter, and it gives me essentially another run-on decimal. Okay, so I would write A times B equals 0.15749130469 which is irrational. Okay, there you go. How you do that? Just put in your calculator. Boom, there you go. It's irrational. Okay. Let's see with your calculator here. Let's see if your calculator will give it to you as a fraction. That would be awesome. Let's see. If I can say this calculator here, I know Desmos will, right? Desmos, if you put it in Desmos and you say 0.44444444, too many fours. See where it says fraction? I hit fraction. It gives it to me maybe in a fraction. But let's see if it keeps going. See, if I keep going, it'll give it to me. This one here, if I do the same thing for the other one, it won't give it to me. It'll just stay as it is, right? If I say 0.3543554, you see how it doesn't give it to me? All right, so this gives it to me as a fraction. Remember, a rational number is a fraction, okay? So this is a fraction. This is not a fraction. That's irrational. 0.4 repeating is rational because it can be a fraction of 4/9. And then just put this in a calculator, right? You can multiply these in a calculator, you get a ridiculous number, and therefore it's still irrational, okay? And just make sure that you write all this down so you get all your points. Next one. All right, next one. So let me erase, clear, erase. All right, your next one here talks about Gabriel going upstream. He's going upstream, and the tour lasts 3.25 hours. The riverboat usually takes 2 hours, 25-mile trip upstream. All right, so upstream is that. So come in here. I'll actually type this stuff in so that way you can see how to work that. So uh, upstream, all right, upstream. Again, your formula that you're using in this is a very basic formula you use all the time. Distance equals rate uh, times time. Okay. If you want to just go ahead and type that all the way out, you can. Distance equals rate times time. Okay. So just use that to help you out through this. The distance, we know the distance is 25 going upstream, right? We know that it takes 2 hours. We know that it takes 2 hours, and we don't know the rate. Okay. So divide 25 divided by 2 equals the rate. And the rate equals 12 and a half, so I'll put that as 0.5. Okay, that's the rate. So now I'm going to say downstream, right? Uh, downstream, again, we're still going 25 miles, and that equals 1.25 times the rate. Which is equal to 25 divided by 1.25, which is, that equals R, which is 25 divided by 1.25 is 20 miles per hour. So this is going 20 miles per hour. That means the boat going upstream is going 20 miles an hour. Coming back downstream probably has the current, means it's going 20 miles per hour. So now I have to look at the, what does he want to do? A 2.5 hour, 20 mile trip. 2.5 hour, 20 mile trip. All right, so let's see if it works using the same rates. All right, so upstream, we're going to go 20 equals uh, 20 equals, let's see, how long is it going to take us? The time, we don't know the time. That's what we're trying to figure out. But we know that it took him 12, he goes 12.5, right, times time. And that equals 20 divided by 12.5. And that equals, again, your time, which is use it in your calculator here, and to say 20 divided by 12.5 is 1.6. So that takes him 1.6 hours. Okay, let's go downstream. Downstream is 20 equals 20t, all right, which means I'm going to divide 20 by 20, and that equals t, my time, which is, of course, 20 divided by 20 is just 1 hour. Okay, so if I add these up, 1 plus 1.6, I get 2.6 hours, which is greater than the 2.5 hour time frame. So no, the 2.5 hour slash 20 mile tour is not possible. There you go. Didn't write a novel, didn't show a whole bunch of work or everything like that. I wrote just the facts, okay? You write just the facts, okay? You write just the facts, all right? And there you go. That is the end of this session.